3 torques T1, T2, and T3 in Newton meters acting on the shaft of a motor. Satisfy the linear equations. 4T1 plus 4T2 plus 2T3 is equals to 3. Negative T1 plus 5T2 plus 3T3 equals to 2. And 2T1 plus 4T2 plus 2T3 is equals to 3. Use Cramer's rule to solve the equations. Solution. So we shall let x equals to T1, y equals to T2, z equals to T3. Therefore, once we write like this, where there is T, we replace with x. Where there is T2, we replace with y. Where there is T3, we replace with z. Therefore, the equation now becomes 4x plus 4y plus 2z equals to 3. Then this will be minus x plus 5y plus 3z equals to 2. Then lastly we shall have 2x plus 4y plus 2z equals to 3. Now this equation we shall write as 4x plus 4y plus 2z. 3 crosses the equal sign into minus 3 equals to 0. Minus x plus 5y plus 3z minus 2 equals to 0. Then 2x plus 4y plus 2z minus 3 equals to 0. Now, Cramer's rule, we know that x over del 1 is equals to minus y over del 2, which equals to set all over del 3, which equals to minus 1 all over del naught. So the signs alternate: positive, negative, positive, negative. Now, we now need to get del 1, del 2, del 3, then del naught. Once we get them, we insert in this equation, and then we shall be able to get the value of z, y, and x. Now, how do we get del 1? Del 1 equals to the determinant of del 1 is associated with x. Therefore, you come to these equations. So we block the coefficients of x because we are dealing with del 1 which is associated with x. We block this and then we write the coefficients of the remaining variables. So del 1 will be equal to 4 to negative 3, 4 to negative 3. Then we have 5, 3, negative 2, then 4 to negative 3. I now expand this determinant. This will be equal to, we take this 4, then we plug this column, and this row will remain 3, negative 2, then 2, negative 3, then minus 2, we take this 2, plug this column and this row, so we have 5, negative 2, 5, negative 2, 4, negative 3. Then it's positive, negative, positive, so we have plus minus 3, so it will be minus 3 into, we plug this into that, so we 5, 3, then 4, 2. Okay, so we now expand this determinant. Before into negative 3 times 3, we have negative 9, minus 2 times negative 2, we have negative 4, minus 2 into negative 3 times 5, negative 15, minus 4 times negative 2, we have negative 8, then minus 3 into 2 times 5, 10, then minus 4 times 3, have 12. Okay, this equals to 4 into negative 9 plus 4, we have negative 5, minus 2 into negative 15 plus 8, have negative 7, then minus 3 into minus 2, this 10 minus 12. So this equals to is minus 20 plus 14 plus 6 minus 20 plus 14 plus 6 is equals to 0. Therefore, what we are saying is that tail 1 equals to 0. Can also now calculate del 2. Now for us to calculate del 2, you come back to this equation. So del 2 is associated with y, therefore we shall log the coefficients of y's, and then we take the other coefficients. So del 2 del 2 we shall have 4, 2, negative 3, 4, 2, we take 4, 2, negative 3, negative 1, negative 1, then we have 3, negative 2, then we have 2, 2, negative 3. and then we expand the determinant. So del 2 will be equal to, we take 4, then we have 3 minus 2, 2 minus 3, minus 2, we plug that under, so we have minus 1 minus 2, 2 minus 3, then of course we have plus minus 3, so we have minus 3, plug that under, so we have minus 1, 3, 2, 2, like that. So this equals to 4 into negative 9, negative 3 times 3, negative 9, minus minus 4, minus 2, negative 3 times negative 1, have 3, minus minus 4, minus 3 into 2 times negative 1, have negative 2, minus 6. This equals to 4 into negative 5, minus 2 into 7, minus 3 into minus 8. This equals to negative 20 plus 14 plus 24. Is positive, negative, or this negative. So equals to negative 34 plus 24, which is equals to negative 10. Therefore, del 2 equals negative 10. So we have now del 2 and del 1, so we can now come and get del 3. So del 3 is associated with z. So in this equation we shall block the coefficients of z. So we are saying del 3 will be equal to, we block the coefficients of z, so we have 4, 4, negative 3, 4, 4, negative 3. Then we have negative 1, 5, negative 2, negative 1, 5, negative 2. Then we have 2, 4, negative 3, 2, 4, negative 3. Then we now expand this. We expand this determinant, D3. This will be equal to 4. We block that column and that row, so we have 4, 5, minus 2, 4 minus 3, minus 4, these 4, that column, that row, negative 1, negative 2, 2, negative 3, then minus 3 into minus 1, 5, 2, 4, like that. So from here we can now expand this. We can do it here. So we have 4 into is equals to 4 into this times that, negative 15 minus 8 minus 8, and then we have minus 4, this 4 into this will be 3 minus 4, so it will be plus 4, then minus 3, this 3 into negative 4, then minus 10. So this will be equal to negative 15 plus 8 will remain with negative 7 times 4, have negative 28. Then we have negative 4 times this is 7, have negative 28. Then we have negative 4 minus 10, we have negative 14 times negative 3 plus 42. So negative 28 minus 28, we get minus 56. So we have negative 56 plus 42 equals negative 14. Negative 14. Therefore, our del 3 equals negative 14. After getting del 3, now need to get del naught. How do we get del naught? For us to get del naught, we now plug the constant terms, and we get the coefficients of this will be 4, 2, negative 1, 5, 3, 2, 4, 2. So we shall say that del naught will be equal to, now it will be 4, 4, 2, 4, 4, 2. Then we have negative 1, 5, 3, negative 1, 5, 3, and then we have 2, 4, 2, 2, 4, 2, like that. So we expand the determinant, it will be 4 into 5, 3, 4, 2, minus 4 into, plug that on that, negative 3 and negative 1 and 3, and then 2, 2. Then we have minus plus 2 into this 2, plug that column on that row, so negative 1, then 5, 2, and then 4. Then we expand this, so we have 4 into, this will be 10 minus 12, minus 4 into, this will be negative 2 minus 6, then this will be plus 2 into minus 4 minus 10. This equals to 4 into this will be negative 2 minus 4 into minus 8, then plus 2 into minus 14. So this is minus 8 minus plus that 2, then this minus 28. So we have minus 8 plus that 2 minus 28. This equals to negative 4. This equals to negative 4. Therefore, del naught equals to negative 4. So we have all the tells. So we go back and we say that that x over del 1 equals to minus y all over del 2, which equals to z all over the 3, which equals to negative 1 all over del naught. So we can start with this, can start with that one. Our del naught so set over our del 3. Del 3 is negative 14. So we have over negative 14 equals to negative 1 all over our del naught is negative 4. Negative 4. So negative 1, so this will be positive, so we have set. So this negative set all over 14 equals to 1 all over 4. Then we cross multiply here. We have negative 4z equals to 14. Therefore, z equals to minus 14 all over 4. 2 here, 7, 2 here, 2, which equals minus 3.5. So that is z. So z is negative 3.5. Then we can get y. So we now come this. So we have minus y over del 2 equals to now this negative 3.5 over del 3, which is del 3. Del 3 is negative 14. Negative 14. And we have del 2. Del 2. Del 2 is negative 10. So we have negative y over negative 10 equals to negative 3.5 all over negative 14. So negative and negatives, all of them are positive. So we have 14 y we cross multiply equals to 35. Therefore y equals to 35 over 14. 7 here, 5, 7 here, 2. So this equals to 2.5. So y equals to 2.5. So once we get the value of y, and then we can now get x from this expression. We have x over del 1 must give us negative y over del 2. Therefore, x over del 1 was 0. Del 1 was 0 equals to y is now 2.5, so we have minus 2.5 over del 2 negative 10. So we cross multiply 10 times, so we have negative 10x equals to 0. So x equals to 0. So after getting the value of x, y, and z, we can now go back and substitute. Remember, we had said that x equals to t1, y equals to t2, z equals to t3. Therefore, t1 equals to 0, t2 equals to negative 3.5, t3 equals to z, which is now z is this 3.5, but this is 2.5. t2 is y, which is this one, 2.5. Thank you for watching.